Electromagnetic induction, types of induced EMF. All of you are aware about Faraday's law of electromagnetic induction, which explains the relationship between electric circuit and magnetic field. This law is the basic working principle of most of the electrical motors, generators, transformers, inductors, etc. You know that Faraday's first law, whenever a conductor is placed in varying magnetic field, an EMF gets induced across the conductor, which is called as induced EMF. And if the conductor is closed circuit, then induced current flows through it. So magnetic field can be varied by either moving magnet or moving coil or by rotating coil relative to magnetic field. So in simple way, whenever magnetic flux links with circuit changes, an EMF is always induced in it, or whenever conductor cuts magnetic flux, an EMF is induced in that conductor. You know the Faraday's second law of electromagnetic induction, which states that the magnitude of induced EMF is equal to rate of change of flux linkage with the coil. The flux linkage is the product of number of turns and flux associated with the coil. That is, magnitude of induced EMF is equal to rate of change of flux linkages. Now we will see different types of induced EMF. Basically, there are two types, statically induced EMF and dynamically induced EMF. Statically induced EMF, in which conductor is the stationary and field is varying by having either alternating source. Dynamically induced EMF, in which conductor is in motion and field is a stationary. Statically induced EMF are also having two types. One is the self-induced EMF and second is the mutually induced EMF. What is this self and mutual induced EMF? So consider one single electromagnet to which it is energized with the battery through which current can be varied. Now this changing, it produces the changing flux. This flux links with the coil and so an EMF is induced in this coil. This EMF will be called as self-induced EMF. So self-induced EMF is the EMF induced in the coil due to change of flux produced by linking it with its own turns. Mutual induced EMF. So consider another coil which is placed near to the first coil. Now current through this coil A is changing by this resistance through this battery, and this flux is produced by the coil A. But the part of this flux links with the coil B. That flux will be called as a mutual flux. This flux will be also changing flux and it links with the coil B, and so as per the Faraday's law, again EMF is induced in the coil B. But this induced EMF is due to the change of flux in the first coil, and so this EMF will be called as a mutually induced EMF, while EMF induced in coil A will be the self-induced EMF. So if flux created by one coil is obtaining joined with the another coil, and as a result of change during this flux created by initial coil, there is induced EMF in second coil, then such EMF is named as mutually induced EMF. So this is the phenomena of mutual induction. That is, if two coils are placed very close to each other in the same plane, a changing current in one coil will induce the EMF in other coil. So from Faraday's law, this EMF in second coil is proportional to rate of change of flux passing through it. So this principle is used in transformer, three-phase induction motor. These are basically works on this mutual induction principle. This three-phase induction motor is the most common drive which is used in the industry. Thank you.